Good morning. In this video, we are going to see how a D flip-flop can be constructed with D latches. We know that both latches and flip-flops are memory elements. Latches are level-sensitive devices, whereas flip-flops are edge-sensitive devices. Here, a D flip-flop can be constructed with two D latches, as shown in figure. The two D latches are connected, as shown in figure. Here, the first latch we call it as master, and the second latch we call it as slave. When the clock is high, master latch is enabled, whereas the slave latch is disabled. Once the master latch is enabled, whatever the input we are feeding at the D will be transferred to its own output Y. At the same time, since the slave latch is disabled, it will not respond to this input. Once the clock is low, master latch is disabled and slave latch is enabled. Since the slave latch is enabled, whatever the input that is available at its D input will be delivered to its output. This is the operation of the flip-flop. Here, the output change only once in one clock period. Change in the output is triggered by the negative edge of the clock. That is, the value that is produced at the output of the flip-flop is the value that was actually stored in the master immediately before the start of the negative edge. Hence, it gains the name negative edge triggered flip-flop. Here, it shows positive edge triggered symbol of positive edge triggered flip-flop and negative edge triggered D flip-flop. Note down the bubble available at the negative edge triggered flip-flop. Characteristic table of D flip-flop. Characteristic table is nothing but it defines the logical properties of a flip-flop by describing its operations in tabular form. When D is equal to 0, Q of T plus 1 is made to reset. When D is equal to 1, Q of T plus 1 is made to set. This is the operation of D flip. A single VLSI chip contains several thousands of gates inside it. And we know that gates are interconnected to form flip-flops as well as latches. Since D flip-flop requires smaller number of gates, it is an economical and efficient flip-flop. There are two other flip-flops which are less widely used but are popular are JK flip-flop and T flip-flops. Now we will see what is a JK flip-flop, and figure shows the construction of JK flip-flop using D flip-flops. This JK flip-flop consists of two inputs J and K and two outputs Q and Q complement. And the actual input that is reaching the D input of the flip-flop is governed by the equation D is equal to J Q prime plus K prime Q. This is derived actually from the circuit diagram. And this is the corresponding graphical symbol of JK flip-flop. Coming to the characteristic table of JK flip-flop, when both the inputs J and K are equal to 0, there will be no change in the output. That is, your Q of T plus 1 is equal to Q of T. When J is equal to 0 and K is equal to 1, the flip-flop is made to reset. When J is equal to 1 and K is equal to 0, the flip-flop is made to set. When both the inputs are 1, whatever was the output, that is complemented. That is, Q of T plus 1 is equal to Q prime of T. Similar to the JK flip-flop, T flip-flop is one more flip-flop that can also be constructed using D flip-flops. Now looking at the diagram, we can say that your actual T input is equal to T XORed with Q. If you apply the XOR formula, we will get T Q prime plus T prime Q. The characteristic table of T flip-flop. When T is equal to 0, Q of T plus 1 is equal to Q of T, that is no change. Whatever was the previous output, that continues. When T is equal to 1, whatever was the previous output, that was complemented. This is the operation of T flip-flop. The T flip-flop, the T stands for toggle.